let's see what we need to do here. A rod of length 10 cm is heated through 100 degrees Celsius or centigrade, and its final length is 10.26 cm. Full stop. What is the coefficient of the linear expansivity? And when you hear the word coefficient, what comes to your mind? Something is attached to it, isn't it? But at the same time, it could be a twist. If you're not careful, it could be a twist. Just let's put down the solution first and see what we are going to arrive at. So I know that initial length is L1 equal to 10 cm, good, is heated through, that's change, heated through 100 degrees centigrade, right? That is change in temperature. Theta 1, theta 2, all right? Theta 2 minus theta 1 has been given as 100 degrees Celsius. And its final length, L2, is given as 10.26 cm. Oh my goodness. If you're not careful, as a student, you'll be thrown off balance by this singular statement, coefficient of the linear expansivity. I think this also means linear expansivity of the material. Because from what has been given, let's see. Okay, our formula is simply linear expansivity is equal to change in length over the original length over change in temperature. That's the formula here, okay? We make no mistakes about this. This is, okay, let's see, it's measured in centigrade, at degree centigrade, not in Kelvin now. So what's the problem here? What actually is the problem here? Okay, now let's substitute. If we have that, we now see that linear expansivity, which is what we are going to calculate. For L2, we have 10.26. For L1, we have just 10.00. I can use 00 to make it of the same weight in terms of decimal values, right? And then L1 remains 10.00, bracket open, change in temperature, because the material has been heated through a certain degree of what? Temperature. That is 100 degrees centigrade, right? So we have 100 degrees centigrade here. And further simplification, we have this minus this is going to be 0.26. And finally, we have 10 times 100 is going to be 1,000. 1,000. Let's see. That's it. That is it. All right? Quickly, do this for me quickly. 0.26 times. Do it for me quickly. I want to know if any of these corresponds. If what I'm going to get corresponds to any of these options given. 0.26 over 1,000. Let's see what we have there. Hold on. You have equal to what? 2.6 times 10 to the power what? Minus 4, right? Degree per degree centigrade. Okay, let's see. We have minus 4, and this is equivalent to, this can be converted to 0.0030 here, and then 26 degree per degree centigrade. Now let's see which of the options correspond. Option number A is 0.026 per degree centigrade, not it at all. Option number B, 0.00, this is 4. Okay, how many do we have here? 1, 2, 3, 4. We have 4 zeros here, 0.00026 per degree centigrade, right? And that corresponds with this. So the appropriate, the suitable option here is option what? B. Option B is the correct option based on what we have. 1, 2, 3, 4. 1, 2, 3, 4. 26 per degree centigrade. All right? So that is it, solved. So most times, a statement might be a twist to know whether you understand what the question is all about. So if you're not careful, or if we were not careful, these coefficients would have been a twist, or would have thrown us off balance, without knowing that what they really want us to find is just linear expansivity of the material. Okay? So it has been solved. Thank you once again. Remain here. I want to see you in my next class.